Hi everyone, in this exercise we'll try to cover a part of the electromagnetic induction, which is chapter 8. Let's start with the given. They said here that the aim of this exercise is to measure the speed of a plane using the phenomenon of electromagnetic induction. In part A, they said that the motion of a conductor in a uniform magnetic field. As you can see here, we have a conductor MN. It's just moving along the positive x-axis to the right side. This is the origin O, and this is the positive x-axis. They said that the length of this rod is L, and it slides on two horizontal and parallel metallic rails AA prime and EE prime. The speed is constant. Its velocity is v vector. During its sliding, the rod remains perpendicular to the rails and its center of mass G moves along the axis OX. Initially, at t equals 0, G is at O. Okay, let's start with the first part. They said that the whole setup formed of a rod and the rails is put within a uniform magnetic field B perpendicular to the plane of the horizontal rails. So the magnetic field is clear. The direction is upward, vertically upwards. We have here the direction of N, which is vertically downwards. Let's check the first part, part 1. Determine at the instant t the expression of the magnetic flux crossing the surface A, M, and E. So must find the flux across A, M, and E in terms of B, L, and X. How can we find the magnetic flux? Okay, so to find the magnetic flux, we can just write first of all the formula, which is N, capital N, multiplied by the magnetic field B and small n vector, finally S. Just capital N represents the number of loops. Here we have one loop, so it's going to be just 1. And B dot N, we can change it into magnitude. It will be B times S times cosine the angle between B and M. You can write it cosine alpha or cosine theta. And reminding you by the summary that I have sent to you, flux, it's N times B times N times S, or NBS cosine theta. In this exercise, N is 1, we have one loop, so N is going to be 1. The formula will be BS cosine the angle. Okay, so here is B, S, which is the area. Since we have a shape of a rectangle, then the area will be length times width. So here it's going to be this shape of A, M, and E will be similar to a rectangle. So we can take X for one side and L for the other side. Then S will be L times X. The final result will just be BLX. Just note something, we have to check cosine the angle between B and M. So here, this angle is between B and M. Let's check if the angle is 0, 180, or different than that. B is upward while N is downwards, so the angle will be 180. Cosine 180 is minus 1. So we have to substitute for this one minus 1, and it will be minus BLX. So the final result will be minus BLX, and that's the last answer. This is part 1, now we can move into part 2. Okay, Part 2, they said, explain the existence of an induced electromotive force E across the ends M and N of the rod. Note that here in this figure, let me just make it a bit clear, the magnetic flux varies. Why is it varying? Since the area is changing. As you know, MN is moving to the right side, so this rod is going along the right direction. Then the surface area for A, M and E is going greater and greater. Since S is changing, then the flux is changing or varying. Then we can say there is an induced electromotive force E across the extremities M and N of this rod. If we just go back to the formula, electromotive force E is minus d flux by dt. This is the formula. If flux is constant, then there will be zero electromotive force. If it is changing or varying, then E will be different than zero. So here in the second part, we can just say that the magnetic flux varies, therefore an induced EMF appears across, as they said in the sentence, the ends M and N of this rod. Part 3, determine the expression of the EMF. Let me just move this one downwards a little bit. Okay, so we have to find the EMF here in this part, in part 3. So E will be equal to minus d flux by dt, which is minus d by dt of the flux, which is minus BLX. The minus and the minus will cancel and there will be plus. B is constant, so it's going to be outside. L is constant, we can throw it outside. And the derivative of x with respect to time is going to be v. So dx by dt is going to be v. We can do it in 2 steps if you want. So we can write it here, dx by dt. All these are constants, b and l, and the answer will be blv. Now let's move to part 4. In part 4 they said no current will pass in the rod. Why? It's clear that there is no closed circuit, so current will not pass in this rod. If we just close the circuit here by adding a wire with a resistor or with something like galvanometer, then the current will start circulating in this rod. But since there is an open circuit, no current will flow. So in part 4, no current since the circuit is open. Step 4. Finally, the last part in this section 5, reduce the polarity of the points M and N of the rod and give the expression of the voltage U and M in terms of E. Let's take a look here. We must find U and M. We usually take the same positive direction. As you can see here, this is the positive direction, so we must start from UMN. Let me just write first of all the formula. I have to take this one also a little bit lower. So this is part 5. So UMN will be equal. I will just move to the summary here. Okay, as you can see here, the voltage of UAB, or it's similar to UMN, we started from A to B along the same direction. So I'm going to take UMN and I copy the same formula, RI minus E. So here it will be Ri or IR, it's the same minus E. Look here. We use the same direction from M to N along the positive sense provided beside this figure. Since no current will pass along this loop, so I will be equal to 0, and we said that, or we provided the reason, then we can just write it's going to be minus E. Then they asked us about UNM, so we can just change it, and UNM will be equal to plus E, which is a positive constant. If we go back to the part 5, they said deduce the polarity of points M and N. Since UNM is positive, then N will be a positive polarity, and this one will be the positive polarity, and this one will be along the negative polarity. Finally, I can just substitute E, which is going to be BLV, so I can copy it, and here the answer will be BLV. That's all. So as a sentence, I can write M is the negative polarity while point N represents the positive polarity. Okay. Let's move to the second part, section B. Here, the measurement of the speed of a plane. A plane is flying horizontally along a straight path with a constant velocity v1 of magnitude v1. Within the uniform magnetic field B of the Earth, the vector B is, or in the region of flight, has a horizontal component of magnitude B horizontal BH and a vertical component BV. So this is the given. We have a plane moving horizontally along this straight path with a velocity v1. We have two components for the magnetic field, one B vertical and the other is B horizontal. They said that the wings of the plane considered as a straight and horizontal conductor of length L prime. So as if we have the same old circuit, and as if we have a rod, it's similar to the rod. Here the name of these points are M and N prime, and we know the length of them. Sweep with time a surface area, so the area is changing here. Part 1a, they said that the magnetic flux of BH. So BH will create a magnetic flux through the swept surface area is 0. Why? Let's first of all write the formula. So the flux will be equal to multiplied by S, or directly we can jump to the last shape. N will be 1, we have one loop. B will be the magnetic field multiplied by the area, and finally cosine the angle between them. Since we'll be using the check here the difference, B is directed horizontally, so B, we are using the horizontal component BH. So B is like this one, like that, and N is vertical, so the angle will be 90 degrees. So it's BHS cosine 90, and as you know, cosine 0 is 1 and cosine 90 is 0, so the answer will be 0. So there will be no magnetic flux, and this is what they are asking us about. So the magnetic flux of the horizontal component of the magnetic field will be 0. There is no effect for this magnetic field. Part B, they said give the expression of the induced electromotive force E that appears between these 2 points in terms of BV. So now we are just using the vertical component. Use the same formula. So the flux for the vertical component, here for the horizontal, it will be BV multiplied by S by cosine the angle. And as you can see here, the vertical component is directed downwards. It's vertically downwards, and N, I'm going to take the same N, which is vertically downwards also, so the angle will be 0. So now in this case, this is B vertical and this is N, while in the previous part this is B horizontal and this is M. So here the angle is 0 cosine 0 1, so it's going to be B vertical multiplied by the surface area S, and the final result will be B V multiplied by the length L prime and X. So it's length times width. Finally, the electromotive force E1 is going to be minus d flux by dt. I'm going to use the same formula, minus d flux by dt, as you can see here. So it's minus here flux of V, vertical component. So it's going to be minus BV L prime. These are constants, and the derivative of X will be V, and especially V1. So it's minus BV times L prime times the velocity V1. The final part, which is part 2. So set in part 2, determine V1 if the potential difference across the wings has a value of 0.3 volts. So if E1 is 0.3 volts, what will be the velocity of this plane? We know that the formula used before, which is U nm equals to E, we can use the same formula. So U nm prime equals to E equals here E1 minus BV L prime and V1. The voltage is 0.36. It's going to be minus B vertical. It's given. The value is 4 times 10 to the power minus 5. 4 times 10 to the power minus 5. So this is the value of B, multiplied by the length, which is 30, as I can remember. Let's check that. It's better. Okay, it's 30 meters, yes. And here is V1. Now we can find V1. Okay. Note that we can't provide the value of the speed in a negative sign. So if you forgot to put absolute value, there will be a minus sign here and you will get a negative answer, which is not the case. So directly, before you substitute the values here, you will use an absolute value for the voltage. So you can put this one in absolute value. You can just use highlight green color. So all the parts will be in absolute value. No negative answers. So here this one will be an absolute value and that one also, and the answer will be positive. No more negative answers. Okay.